Welcome back. Now we look at comparison of means. So if the Anova indicates the means are not all equal, then I can work out how they're different. Now there are various ways of doing this. Now obviously if I am taking a look at pairwise comparisons, then the more comparisons I do, the more chances I have of making a type 1 error. Now the problem here is that I'm fixing my significance level at 5%, and in fact if I take a look at 20 comparisons, that means 1 in 5% of the time, in other words 1 out of 20 I'll get wrong. So K groups, the number of pairwise comparisons is going to be, oops, I've got this wrong, it should be K choose 2, excuse the typing, and that's essentially K choose 2. For 4 groups this means I've got 6 pairwise comparisons. For 10 this is 45, so with 10 groups I'm almost surely going to make 1 or 2 errors in these comparisons. In other words, I'll decide the means are not the same when they actually are the same. Now what we do is we adjust for these multiple comparisons, and there are many ways of doing this. One for erroneous correction is one you might find in the literature. There is the Tukey-Kramer procedure, and that's what we will be using here. And so the Tukey-Kramer procedure gives you a p-value, and you can use that to decide. So here's an example. We're looking at the transport costs in these 4 cities, and we want to take a look to see if they're the same or not the same. So here is the R output, and you can see the p-value is small, which means that the mean costs are not all the same. And below I've got the means and variances, means and standard deviations. You can see here, if I look at it, the lowest mean is Melbourne, then I'm going to have Perth, and then Brisbane, and then Sydney. But these are just the actual means. I don't know if these means are significantly different or not. So if I perform the Kramer-Tukey procedure, and R does this for you, it tells you multiple comparisons. What it does give you is a p-value. And so by looking at the p-values, I can find that Sydney and Melbourne are different, and Sydney and Perth are different. But Perth and Sydney are not different. Sydney and Brisbane are not different. The p-values here are large. The star p-values are less than 0.05. So Perth and Brisbane are the same, Sydney and Brisbane are the same, Perth and Melbourne are the same, but Sydney, Melbourne and Sydney, Perth differ. A simple way of presenting this is in this form, where I list the means in order, and as I decided earlier that Melbourne, Perth and Brisbane were all the same. Yeah, Melbourne, Brisbane the same, Perth, Brisbane and Perth, Melbourne. But that Sydney and Perth and Sydney and Melbourne are different. Now what's the one statement I can say here? Certainly I can't say that Sydney is different from Brisbane. If I say Sydney is different from certainly I can't say that Brisbane is different from Perth, because these 3 are the same. The one thing I'm seeing clearly is Sydney is different from Melbourne and Perth, and that Sydney actually is higher than Melbourne and Perth, and that's the one statement I would write down here. Don't try and in any way hypothesize or put more in there than you can see. That's what I see clearly. Sydney is higher than Perth and Melbourne, so I've just said exactly that. And then finally my summary. Understand the structure, data structure for Anova, state hypothesis of interest, understand the structure of the Anova table, test hypotheses and state conclusions, verify assumptions for Anova, be able to work out the common variance, and then confidence intervals, and then post hoc tests using Kramer-Tukey procedure, as you will see. Thank you.